This whole next chapter or unit is on right triangles, and we're going to be learning how to find missing sides of right triangles, how to find missing angles of right triangles. So we're going to start with one of the most popular theorems and equations in all of math, and that is the Pythagorean Theorem. So you might have seen this before. It is a squared plus b squared is equal to c squared. It was named after Pythagoras, a Greek mathematician. So it's important that we establish what A, B, and C stand for. The most important variable in this equation is C. C represents the hypotenuse, which is the longest side. The longest side is always going to be across from the right angle. The other two sides are called the legs, and that A and B can be changed back and forth. It won't make a difference. C, it cannot, because it has to be the longest side. The other word that we're going to focus on at the beginning is called a Pythagorean triple. All of these Pythagorean triples are nice because there's no decimals. They're nice whole numbers. So let's say, for example, I look at the smallest one, 3, 4, and 5. 5 has to be my hypotenuse because it's the longest side. So that means when I take my legs squared plus my legs squared, and I try to figure out what my hypotenuse is, which I already know it's 5, I'm going to get a nice whole number. So 3 squared is 9, 4 squared is 16. That's going to give me my hypotenuse. When I add 9 and 16 together, I get 25. That is equal to c squared. 25 is a perfect square. So when I take the square root of both sides, I get a whole number of 5. So Pythagorean triples have that special name because when you take the square root of that value, it ends up being a perfect square. So what are these examples going to look like? They're going to want us to find missing lengths or missing sides of the triangle. So they want us to find the value using the Pythagorean theorem, so a squared plus b squared is equal to c squared, and then determine if it is a Pythagorean triple after that. So I'm going to label my sides. The most important side is the hypotenuse, which is directly across from the right angle. So we're going to let our variable of x be the hypotenuse, or c, and then the other two sides are my legs, so a, b. So I'm going to fill in. My a value is 5. My b value is 12. And c is what's missing. You can put that as x, you can put it at c. It doesn't matter because it's a missing variable. And then I'm going to simplify. I'm going to do exponents first. So 5 squared is 25. 12 squared is 144. Combine my like terms. So 169 is equal to x squared. And that last step, most important step, is to take the square root of both sides, because the opposite of squaring is the square root. And this missing hypotenuse is 13. Since I got a nice whole number, that means yes, this is a Pythagorean triple. If I were to take the square root and it ended up being like 13.7, anything but a whole number, then it would not be a Pythagorean triple. In the second example, we're going to try to find a missing leg. So if you notice, the side across from our right angle, they gave us the value of the hypotenuse, so they gave us c. That means that we're missing one of the two legs, and it doesn't matter which one you label a, which one you label b. So our Pythagorean theorem is a squared plus b squared equals c squared, and I'm going to fill in for what I have. So I let my a value be the missing leg, so I'm going to make that x squared. My b value is 7. My c value is 14. This is going to start off the same exact way. I want to do my exponents first. So I'm going to simplify. 7 squared is 49. 14 squared is 196. A little bit different because I'm solving to get x by itself. So I'm going to subtract 49 from both sides. And I get 147. Final step, opposite of squaring is taking the square root. And the square root of 147 is 12.1. We're going to learn eventually how to break these square roots down so we don't have decimals, but for now we're just going to round to the nearest tenth. I put in, this means approximately, so x is approximately 12.1 since it is a decimal. Since I got a decimal, that means no, this is not a Pythagorean triple. Next, we can determine whether, if it's not, next we're going to see if we are given three values, when I take a squared plus b squared equals c squared, do both sides equal each other? If they do, then that determines that it is a right triangle. So I'm checking to see if the two legs, when I square them and add them, does that equal the third side? All right, I'm going to just look to see what is the square root of 113. So this is approximately 10.6. That's very important because that's my longest side. So that determines that this is my C value. The longest side will always be the C value, and then it doesn't matter which one we label A and B. So I'm going to check to see, does A squared plus B squared equal C squared? So my A value I would let be 7. My B value is 8. My C value is the square root of 113. Notice that I used radical 113 rather than that approximation. All right, so 7 squared is 49. 8 squared is 64. Now when I take the square of a square root, they're the inverse of one another. So all they do is simply cancel each other out, and we're left with 113. So simplifying the left-hand side, 49 plus 64 is 113. Since my leg squared plus my leg squared equals my hypotenuse squared, I can conclude that this is a right triangle. All right, so let me just check to see what the square root of 95. So the square root of 95 times 4 is 38, approximately 38.99. So that makes that my hypotenuse, which is my longest side. So it's very important that we establish that. And then I'll let my other two sides be A and B. All right, so I let my A squared be 36. So I have 36 squared plus 15 squared is equal to 4 radical 95 squared. And I want to see if the left-hand side is equal to the right-hand side. So 36 squared is 1,296. 15 squared is 225. Now, I'm going to square both of these separate, so I'm going to do 4 squared, which is 16, times, remember, the square root cancels with the square, so times 95. 16 times 95 is 1,520. And then 1,296 plus 225 is 1,521. These are not equal, so our second example is not a right triangle. our last example is, well, if it's not a right triangle, we can then determine if it's acute or obtuse. So if it's an acute triangle, that means that the hypotenuse is going to be less than the legs. If it's an obtuse triangle, that means the hypotenuse is going to be greater than the legs. So I have lengths of 4.3, 5.2, and 6.1. It's important to establish the hypotenuse. The hypotenuse is the longest side. So 6.1 is going to be my C value. So I want to see what is the relationship between A squared and B squared compared to C squared. If it is less than, it's acute. If it's equal to, it's right. If it's greater than, it's obtuse. So I'm going to fill in my values. So I'm going to compare 6.1 squared to 4.3 squared plus 5.2 squared. All right, so 6.1 to the second power is 37.21. The right-hand side's a little bit more work. 4.3 squared is 18.49. 5.2 squared is 27.04. When I combine that together, I get 45.53. So how does that compare? 37, our hypotenuse, is less than the sum of our two legs. Since it's less, that makes it an acute triangle.